Homework. Question on any of the homework assignments so far?
Of course you have. I'm just trying to find it. What? You kicked me out of my mom's class.
Well, maybe if you weren't ginger.
Guys.
Ooh.
Guys. Guys.
Sorry.
What we're doing today is we're solving these rational equations. We're solving rational equations. Now, the first thing we need to do with solving rational equations is make sure that the denominators, the bottoms of the fractions, are factored simplified as possible, so that we can, one, find the least common denominator, which we're going to use to help us solve these, and be able to find the restrictions. So our restrictions are any value of x that would make a denominator be 0. So here there's two places where the denominator could be 0. One of them is going to be x plus 1, the other is 4x plus 5. Because if a value of x makes either one of these be 0, the denominator would be 0, and that will not work. We have to remove those solutions if they do show up. So with x plus 1, first thing we can do is subtract 1 from both sides, telling us that if x is negative 1, it would give us a denominator of 0. It cannot be a solution. It's an extraneous solution. 4x plus 5, first thing we would need to do is subtract 5 from both sides, telling us that if 4x is equal to negative 5, giving us 4x equal to negative 5, then we're going to divide both sides by 4, telling us that if x is equal to negative 5/4, bless you, we'd get a division of 0 that would not work. So if one of the solutions is negative 1 or negative 5/4, we would have to throw that solution out. It would be an extraneous solution. Next thing we need to find is the least common denominator. Least common denominator is going to help us be able to solve this here. So our two denominators are x plus 1 and 4x plus 5. One of our terms for the least common denominator is going to have to be x plus 1, because it does show up in one of the denominators. We only need it once because it shows up once. What else do we need? Plus 5. And we only need it once because it only shows up once. Now with solving this here, unlike our complex fractions or adding and subtracting fractions, we're going to take this least common denominator and multiply it through the equation. So we're going to multiply every term in this equation by the least common denominator. And the goal in doing this here is to simplify the fractions, because it's going to be easier to solve if we don't have the fractions there. Now, when we multiply this with the 3, we're going to get 3 times 4x plus 5 times x plus 1 on top. And on bottom, we're going to have x plus 1 is equal to. On our other side, we're going to have 9 times. Yes, sir. 4x plus 5 times our x plus 1 over, bless you, 4x plus 5. Okay. Yeah. Yeah. Thank you. Now, if we look at the fraction on the left, we have an x minus 1 in common on top and bottom. That will cancel out. And what that leaves us with is 3 times
Supermont, come to the office. Supermont,
4x plus 5. On the right-hand side, the 4x plus 5 and 4x plus 5 will cancel, leaving us with 9 times x plus 1. So multiplying through by that least common denominator reduced all the fractions and just gives us an equation to solve. Now the first thing, or next thing we need to do is simplify these parentheses. 3 times 4x is going to be 12x. 3 times 5 is plus 15. 9 times x is going to be 9x, and 9 times 1 is going to be plus 9. Now since there's not an x to a power greater than 1, we don't have x squared, x cubed, any of these here. At this point here, we just need to get x by itself and everything else on the other side. So what's our next step here? Minus 9 what? Minus 9x, yes. We can subtract 9x from both sides. Now 12x minus 9x will give us 3x. Plus 15 is equal to 9. What can we do next? All right, guys, up here. What can we do next? Minus 15. Because our 15 minus 15 would be 0, telling us 3x is equal to negative 6. By what? Divide both sides by 3. Telling us x is equal to negative 2. Is that one of our restrictions? No, so it is a solution. The nice thing with restrictions is we don't have to plug it back in to check to see does it work, is it a solution, or is it an extraneous solution, one that we get from solving but does not work in the original context. Questions on this here? Restrictions. So there's two places that the denominator can be 0. Either x plus 2 is 0, or 3x plus 2 is equal to 0. With our x plus 2, to see what value of x will make it be 0, we can subtract 2 from both sides, telling us that x is equal to 0 here when it is equal to negative 2. X cannot be negative 2, because if x is negative 2, one of the denominators will be 0. Our other equation, 3x plus 2, the first thing we can do is subtract 2, telling us that if 3x is equal to negative 2, or telling us that, and then divide by 3, tells us that if x is equal to negative 2/3, the other denominator would be 0. We can't have the solution being negative 2 or negative 2/3. Now our two denominators, x plus 2 and 3x plus 2, are both of those simplified? Or can one of those be factored? No. X plus 2 is simplified as it gets. 3x plus 2 is as simplified as it gets. So when we multiply by the least common denominator, we're trying to get rid of all the denominators out of each fraction. So if we multiply through by x plus 2, on the left-hand side, this x plus 2 and this x plus 2 will go away. How about on the right-hand side? Well, no. 3x plus 2 and x plus 2 don't match up. So we're also going to need to multiply through by what? 3x plus 2. It's here. Now the 3x plus 2 and 3x plus 2 will cancel, because the least common denominator for this is x plus 2 times 3x plus 2. That's the least common denominator. Now let's see what that leaves us with. On the left-hand side, we still have our 2, and it's being multiplied by 3x plus 2. And that's going to be equal to 10 times x plus 2. 2 times 3x. 2 times our positive 2, 4, is equal to, yes, 10x plus 20. What can we do next? Yeah, so we can minus 6x from both sides. We can minus 4. I wouldn't minus 4 because we're trying to get the x by itself, yes? Minus 20. Now, minusing the 4 would work and would be a good option, especially if we had x squared x in a constant term, we had x squared and x, then we do need it equal to 0. But here, since we just have x, or if we just had, say, it would have been 4x squared, yeah, get the constant term by itself, get the term, or singular variable by itself, and we can solve from here. Because at this point, we can divide by 4. Yes. Is that one of our restrictions? No. That's it. Questions on any of this here? Two denominators that we have are 5x and x minus 7. 5x cannot be 0, because if 5x equals 0, the denominator would be 0. It's not going to work. That's the only number we can multiply with 5 and get 0. 0. So here it's really saying that x cannot be 0. Also, our zero product property state that if we multiply any two things together and get 0, one of them has to be 0. Well, our two things are multiplying together is 5 and x. Well, the one is going to be 5. X has to be 0. What number minus 7 is 0? So if we said x is equal to 7, well, 7 minus 7 is 0, so x cannot be 7. What's our least common denominator for this equation? 5x and 5x and x minus 7. 5x times x minus 7. So we're going to have to multiply the whole thing by 5x times x minus 7. On the left-hand side, the 5x and 5x will cancel. On the right-hand side, the x minus 7 and x minus 7 will cancel, leaving us with 3 times x minus 7 is equal to 2 times 5x is 10x. Our next step is to distribute the 3. 3 times x is 3x. 3 times negative 7 is negative 21. What can we do next? Well, our next step would be 2 minus 3x from both sides. 7x is equal to negative 21. Questions on this here? Yeah. the two places where x, we cannot get a value of 0 is when x is x plus 3 or x minus 3. Because if x plus 3 becomes 0 or x minus 3 becomes 0, then we have a division of 0 that does not work. Well, what number can we add to 3? Negative 3. How about x minus 3? 3. So if x is positive or negative 3, we have a division of 0 that does not work. We cannot get, or cannot have an x value making the denominator be 0. I mean, we could have calculated this out and just done minus 3, or here plus 3 and plus 3. Least common denominator is what? X plus 3 and x minus 3. So we're going to multiply every part, every fraction, or every term in this equation by x plus 3 and x minus 3. Now on the left-hand side, the x plus 3 and x plus 3 will cancel, telling me that negative 4 times x minus 3 is equal to, well, on the other side, the x minus 3 and x minus 3 will cancel, telling me that I have 5 times x plus 3. So again, using these least common denominators help us get this equation that's easier to solve. Negative 4 times x is negative 4x. Negative 4 times negative 3 indeed would be positive 12. 5x plus 15. Yes, now we need to get x by itself, so we'll add 4x to both sides. Minus 12 is equal to 9x plus 15. And minus the 15, so we get the x by itself. 9x is equal to negative 3. And lastly, divide by 9. Yes, to negative 1/3. Negative 3 over 9 is going to simplify to negative 1/3. Questions on this here? Now, restrictions for this here, x, I'll tell you, cannot be negative 5/2 or negative 8/11. Just not going to work if we have either one of those. Now, the first thing we need to do is to multiply by our least common denominator, which would be what? 2x plus 5. And 11x plus 8. And luckily, so far, all of our denominators have been simplified. We don't have to do any factoring, nothing to them. So we are able to just grab them like we have been doing. Now here, the 2x plus 5 and 2x plus 5 will cancel. 11x plus 8 and 11x plus 8 will cancel. Leaving us with 1 times 11x plus 8, well, that's just 11x plus 8 is equal to x times 2x plus 5. X plus 8 is as simplified as it gets. There's no like terms we can combine. There's nothing we can do with it at this point. On the right-hand side, we will need to distribute the x. X times 2x is 2x squared plus 5x. Now, this is the first one we've had today where we actually have a variable with an exponent bigger than 1. We have a 2x squared. So the first thing we need to do is get this equation equal to 0. So what can we do first? I would go the other direction because I would go towards the 2x. I wouldn't subtract the 5x. So we can do what? We can subtract the 11x. 8 is equal to 2x squared minus 6x. Next thing we can do is subtract the 8, telling us 0 is equal to 2x squared minus 6x minus 8. Now looking at this here, we need to solve this quadratic equation, 2x squared minus 6x minus 8. Yes, sir? Yes. We can factor this. Is there a greatest common factor between 2x squared, 6x, and 8? 2. And if we factor that 2 out, we're left with x squared minus 3x minus 4. Two sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. One is going to be positive, one is going to be negative. Factors of x squared, x and x. Now our factors of 4 are 1 and 4 or 2 and 2. 1 and 4. Where do you want to put the 1? Where do you want to put the 4? And these would indeed be the correct factors. Now, again, we're solving. We're trying to find out what values of x will make this equation equal 0. That's why we set it equal to 0. Well, if we have 2 or more things that multiply together to equal 0, one of these has to be 0. Well, with our x plus 1, minus 1 from both sides, telling us that x is equal to negative 1. Here we can add 4 to both sides, telling us that x is equal to 4. We could have also graphed this quadratic equation, 2x squared minus 6x minus 8. So we could have gone y equals 2x squared minus 6x minus 8. Graph. We do see that it crosses the x-axis at 2 spots, which are negative 1 and 4. So again, when we graph it, we're looking for what values of x will make the y value be 0. Are either one of these our restrictions? No. So those both work. They're both solutions to this here. We will finish this on Monday.